Okay, so find the coordinates and nature of each of the stationary points on the curve. So we've got here y equals 2x cubed minus 6x plus 5. Okay, now I've sketched a brief sort of graph here, all right, for you to see what stationary points are. Now, stationary points are what we've got here, okay, and here, all right, where basically the graph starts to turn. So if you notice here, it's increasing, and then at this point it turns, okay, and then it starts to decrease. And the same here then. The graph is decreasing, and then it turns and it starts to increase. We also call them stationary points because you actually come to a stop, don't you? At a station, like a railway station, the train comes to a stop, and here you come to a stop as well. If you were climbing up a mountain, you would come to a stop at the top, wouldn't you? Okay, so think of it like that. Now, at these stationary points, okay, we need to appreciate what the gradient is. Now, we can get the gradient by drawing a tangent, can't we? If I drew a tangent at the top there, remember the tangent touches the curve just once. So if I drew a tangent there, it would actually be a horizontal line, okay? Horizontal line. And the same here, at the bottom. If I drew a tangent here, it would be a horizontal line. Okay, that's important. Now before that, if we were climbing, if we were on our way up the top of the mountain, we've got a positive gradient and the tangents are positive, okay? But when we climb down the mountain, it's negative, okay? Because we've got negative gradients, right? The tangents are going this way. So if we go from positive to negative, in the middle, of course, then we'll have 0, if you think about it, because positive values here, gradients here, negative gradients here. So going from positive to negative must mean we have 0 in the middle. And you expect that, don't you? Because we've got a flat tangent here, yes, horizontal. So that means the gradient is 0. So what we can say is, at stationary points, dy dx, which is the gradient function, remember, is 0. Okay, dy dx is 0. Right, so we need to work out dy dx. So maybe I could do that before here. Dy dx equals 6x squared minus 6. Okay, so you bring the 3 down, times it by the 2, so you get 6, and then reduce that power by 1. And of course then 6x just becomes 6, so we've got a minus in front. Alright, so we could say at the stationary points, our dy dx is 0. Right, so tangents there flat. So if we set dy dx to equal 0, we've got this then function there to equal 0. Okay, 6x squared minus 6 equals 0. We can easily solve that. We'll just take the minus 6 over, there's a plus 6. And then to get x squared then, we take the 6 over and divide by 6. So then x squared will equal 1. Now if x squared equals 1, we need to get x, which means we need to square root. Okay, so we take the square over and square root. But when we square root, remember, it's got to be plus or minus 1. Okay, so x will equal 1 or x will equal minus 1. Remember, it can equal minus 1 because when you square minus 1, you get 1, don't you? Okay, so it can be positive or minus. So now what we'll do, we'll work out what y is. So when x equals 1, y will equal 2 times 1 cubed minus 6 times 1 plus 5. And that's easy, isn't it? 2, that'll become 2, that's just 6. So 2 minus 6 is minus 4, plus 5 is 1. Okay, and then when x is minus 1, y will equal 2 times minus 1 cubed minus 6 times minus 1 plus 5. You might want to use a calculator in this instance, even though you could do it in your head, but just be careful with the minus 1. We don't want to make a mistake. Okay, so type that in the exam, just to double check, you make sure you're doing everything right. Okay, so I made a mistake there, right? I missed out the 1 there. Okay, so I've got that typed in there. If I write that in, I get out 9. Okay, so my stationary points are 1, 1, okay, x is 1, y is 1, and minus 1, 9. Alright, so what we need to do now, if we go back to the question, remember we need to determine their nature. We need to see, are they a maximum or a minimum? Okay, that's a maximum, that's a minimum. In order to do that, you do the second derivative, right? You've always got to work out d2y by dx squared. d2y by dx squared. So you differentiate this again. If I differentiate this again, 2 times 6 is 12x, yeah? You reduce that power by 1, so you get 12x, and the minus 6 just it becomes 0. So that's the second derivative when you differentiate this again. And then all you need to do is, you need to put those values of x in here to see what dy dx is. So when x equals 1, d2y by dx squared will equal to 12 times 1, which equals to 12. Now it doesn't matter what it comes to, what's important is whether it's positive or negative. In this case, it's positive. So if it's a positive, we know it's a minimum. Okay? If it's a positive. Doesn't matter what it comes to, what value it comes to, but the fact is it's positive. So my 1, 1, the first point there, is a minimum. That's the nature of it. It's a minimum stationary point. And then we do the other one. When x equals minus 1, okay, d2y by dx squared is equal to 12 times minus 1 is equal to minus 12, and that is less than 0. And if it's less than 0, it's a maximum. Okay, so it would be a maximum turning point. So it'll be like that, yeah? Whereas this is a minimum, it'll be like that. It'll be at the bottom there, and this will be at the top. So we say then minus 1 and 9, yeah, is a maximum. It's important there that you are clear here in your final answers.